So good morning everyone, myself Anubhav Gupta, and I am here for presenting my paper Finding Influential Institutions in Bibliographic Information Network. That was, and this paper describes my work, my approaches that I used in the KDD Cup, KDD Cup 2016. And one of the other authors of this paper is M.N. Murthy, and I am here representing Indian Institute of Science. And here is a brief outline of my presentation. So first, I am going to introduce the problem and then give the brief motivation behind the problem, and then I will describe some of the assumptions that are necessary for a proposed methods, and then I will describe our methods that was used in the competition, and then I will describe the experiments, and then finally conclude the presentation. So as how already is described, so this slide is just for representing the problem. Most of it was already described. So as the input is the name of any conference, for example KDD, and then what we have to do, we have to predict the influence of institutions for this particular conference, and then this influence is it means that we have to predict the ranking score of institutions for this particular conference, and then the question is how to measure the influence of an institution. And as I already described, to find the influence of any institution, the criteria we are using here is the number of papers. So how to find the number of papers of any institution in a particular conference? So for that, what we are doing, we are taking the path from a conference, and we know the papers accepted in a conference. So for all the papers, we know their authors, and then authors are associated with their particular institutions. So this metapath is used to get the relationship between the conference and institutions, and we count these links to find the number of research papers from a particular institutions in any particular conference. So these are the assumptions that were imposed by the KDD Cup organizers. So each accepted paper is equally important. This is one of those assumptions, and this assumption makes sense because we don't know whether which paper is going to have influence in the future. So this is assumption. This is one of the assumptions, and other assumption is that if a paper has multiple authors, then all the authors are supposed to have equal importance, equal contribution to the paper. And the other assumption is that if an author is affiliated with multiple organizations, multiple institutions, then each of those institutions have the equal contribution to the paper. And in the competition, we have used two different approaches, and we have named them like Rankins 1 and the other one is Rankins 2. And this first method, Rankins 1, was used in the first two phases of the competition, and the other method is used in the third phase. So Rankins 1 is just a simple method. What it does, it just uses the past data to predict the rankings, to predict the influence of institutions in a particular conference. So our intuition behind this approach is that the recent years are given more weightage than the previous years. And here what we are doing to predict the ranking of any institution in a particular conference, we are just taking the weighted average of the number of papers by that institution in the conference in previous years, and to compute these weights, we are using the Brown's simple and exponential smoothing, and this is how we are using. So to predict the ranking score of a particular institution in year 2016, we take the weighted average of the ranking scores of the institution in previous years. And the other method that we are using, this method is this is also supervised learning. So both of these methods are supervised, use some supervised techniques to find the ranking scores of institutions. So this method, so first I'll briefly describe this and give an overview of this method. So in this method, what we are doing, we are calculating the data metrics for the year 2016 for a particular conference that we want to predict the rankings for, and then we use some learning to rank method to predict the ranking of institutions in year 2016. So here's the outline. So first we'll represent the institutions and conferences as well as feature vectors, and then we construct the data matrix up to the year 2015. That is the training data that we have available. So we created the data matrix up to that year, and then we use these data matrices to create the data to find the data matrix of the year 2016, and then use the data matrix of year 2016 as our test test set, and then predict the rankings of on the test set. So how do we construct the feature vectors of institutions as well as conferences? So to construct the feature vectors, the two types of attributes that we are using are the authors of the institutions as well as conferences, and the topics of the research papers that are being published. So instead of using the individual authors, we are using clusters of authors. And to perform the clustering of authors, we are using the rankings of the authors as a criteria. And the other thing is topics of research papers. And these topics are to find these topics, we are using the keywords that is associated with every paper in the Microsoft Academic Graph dataset. And then now how to create the data matrix. Now to create the data matrix, the feature vector for a conference institution pair that is obtained by getting the element wise multiplication of the feature vector of conference as well as feature vector of institution. And then the data matrix is nothing but the data matrix corresponding to conference CB is then nothing but these feature vectors of the conference institution pair in the order. So this gives us the data matrix for a particular conference CB. After that, we use these data matrices to find the data matrix for year 2016. And here we are assuming that the data matrix of year 2016 is a linear combination of data matrices of previous years. And now the question is, how do we find these weights W1, W2 and W3? And to find these weights, we use a iterative method. In this, we first find the initial weight vector W0 that is obtained by optimizing this, by solving this optimization problem, and then we go backwards and then we solve this optimization problem. And here the intuition is that the data matrix of any year that is mostly influenced by data matrix of the previous year, and then the data matrices of data matrices of previous years also affect that, but that weight that parameter that is controlled by this lambda. And then how do we compute the rankings? To compute the as I described already, first we learn the ranking model using the data up to year 2015, and then use this data matrix that is MHEAD 2016 as the test data, and then use the ranking model on this test data to predict the rankings in 2016. And the dataset used in this computation was taken from Microsoft Academic Graph. And the dataset also contains two specific files that are required for this computation. One file contains the name of the affiliations for which we have to predict the rankings, and the other file contains, as the Microsoft Academic Graph, it contains the information about all of the papers, and it contains the full papers as well as short papers, workshop papers. Everything is there. And this file that was specifically provided for this computation 2016 KD Cup selected papers. This file only contains information about the full papers, as the competition only asked about the number of full papers accepted by any institution. And for our experiments, we split the dataset into two parts, that is training set and validation set. The training set consists of all the data up to year 2014, and the validation set contains the data, the graph that is constructed from all of the research papers that were published in year 2015. And then the authors are constructed based on their rankings. And to calculate the rankings of authors, we are using all the papers, not just the full research papers. And the rankings of authors, these are computed by using their citation counts. So this is a simple ranking of authors. And for evaluation, the matrix NDCG is used, and this is a standard metric for evaluation of rankings. So NDCG is calculated as follows. And the results that we obtained on the validation set. The validation set, for the validation to compute the validation set, we train our ranking model on the data up to year 2014, and then we predict the ranking on 2015. So this is the result that was obtained on the validation set. And here the previous year is what the ranking we are obtaining by just predicting the ranks of institution that was in the previous year. So for predicting the rank of any institution in year 2015, we just predict its rank in year 2014. So that is previous years. So as we can see from this, the both of our approaches that work much better as compared to previous year rankings. And the results on the competition that was the test set are as follows. So from as we can see from here, the rankings 2 performs better for the, these are the 3 conferences that we have to submitted results, the rankings for in the final phase. So in the here we can see that rankings 2 perform much better than rankings 1. And as you can see, the NDCG scores are pretty low for the last 3 conferences. So NDCG scores being low means for these 3 conferences, the number of research papers from all of the institutions, they are varying. They are not in a constant way, because here if we see in the previous year rankings, for previous year rankings, the NDCG score are very high. So that means it follows some pattern, the number of research papers accepted. But for the last 3 conferences, it is not following any pattern, and our approach rankings 2, it in a way finds it and handles this case. So is the conclusion. Both approaches consider the, so both of the approaches are supervised approaches, and in both of the approaches we are considering the heterogeneous network as a dynamic network. We are not considering it as a static network. And the approach rankings 2 performs outperforms rankings 1 in 3 conferences, and the other one outperforms in 5 conferences. Thanks.
Quick question, can you give any intuition when rankings 1 is outperforming versus when ranking 2 is outperforming?
So what rankings 1 is doing, rankings 1 is just inherently giving the weightage in the recent year, the weightage of the rankings in the recent years. It's giving them more weightage than the previous years. But rankings 2, it is not like that. Sorry. In the rankings 2, we have one parameter, lambda L. But by lambda L we can specify whether we want to give more weightage to previous year rankings or not. Like if we want to give, say for predicting the ranking of 2016, if we want to give the rankings of 2013 more weightage than 2014, then that can be done in this rankings 2. But for rankings 1, we are giving the 2015 more weightage than 2013. That is always the case there. But that can be, but it can be the case that for one particular year, that was kind of, you can say outlier for some institutions, that this particular ranking for some of the institutions, they just couldn't get as much papers as they always get in one particular year. Then rankings 1 will not be able to identify that. But rankings 1 can do, rankings 2 can do.
Any other questions?
When you talk about the ranking, are you saying the NDCG 20, or how did you define your ranking here?
How I define ranking?
Yeah, how did you define?
So here ranking means as a competition problem is there. So we have to predict the number of papers, the fraction of papers from every institution in a particular conference. So we have to specify how many of the research papers are going to be accepted in, for example, KDD. In KDD 2016, how many number of papers are going to be accepted by this particular institution. So here ranking is based on how many papers are going of them being are accepted. Yeah, it's based on just number of papers.
Okay, well, thank you very much. I appreciate your talk. Thanks for going first this morning.
Thank you.
One more round of applause here. Thanks.